session, session 19. We have two topics in session 19. The first one is feeder separation project. We discussed a little bit about it yesterday. Paying feeder and non-paying feeder, I mean agricultural feeder and non-agricultural feeder. Is it good? Is it bad? What are the implications of having this feeder separation project? And then we are also going to discuss, can IT revolutionize electricity distribution? Do smarter grids need more regulatory and policy support? We have two speakers, Mohammad Suleman. May I request Mohammad Suleman to kindly come to the dais? And Dr. Shailendra Fuloria. Dr. Fuloria, kindly come to the dais. This will be a kind of, you say for about 6-7 minutes, Welcome to you, Mohammad Suleman and Dr. Fuloria. Mohammad Suleman is the Secretary of Energy MP. He is a 1989 batch of IAS from MP. He is a civil engineer by qualification, and he is working in the power department for 2 years. Welcome to you, Mohammad Suleman. We have with us Dr. Shailendra Fuloria. He is the head of Smart Grid and Cyber Security Verticals ABB India, and he holds a PhD in security engineering from the University of Cambridge, UK. Currently, he is the co-chair of the working group on cyber security in the India Smart Grid Forum. So again, this session will be for about half an hour. I would request the eminent speakers, topics are different, to restrict within 10 minutes. And maybe if we chance, if we finish it by 20 minutes, we'll have 10 minutes for questions and answers. So over to you, Mohammad Suleman.
Well, good morning, everybody. I intend to keep the time schedule of 10 minutes. Can you just get it done? Well, I'm here to talk about a dream of the people of Madhya Pradesh. I call it dream because it sounds so. And the dream basically says that we need to have 24-hour power supply to every household in the state of MP. And I say dream because in a state which has seen shortages for last 10 years, to reach a stage in which every household gets 24-hour supply can only be considered a dream. At least my children think so, if not else. I mean, whenever I tell them, they somehow don't really agree that it can be done. But this is what we are all set to do. This team has an absolute and complete political commitment, absolute administrative commitment that we need to deliver. And I'm here to talk about the challenges that we face and when we fulfill this dream. We need to have 24-hour supply, and that too starting sometimes in early 2013. A few months down the line, we need to start supplying this 24-hour power to every household. So these are the challenges that we notice if we need to fulfill this dream. We need to really find out what kind of energy requirement we would have. How do we procure enough energy? What are our long-term, short-term, and medium-term procurement plan to fulfill this dream? What kind of a transmission network we need to have to evacuate this power to every household? What kind of a distribution system we should be looking at? I'm not talking of these all four. I'm talking of the last of it, commercial viability of operation. How do we survive if we supply 24-hour power to everybody? You know that the more energy that we supply, the more money we lose. In fact, the real challenge is the commercial viability of operations when we want to supply energy to every household, more so when we target the rural areas. In fact, the entire challenge in the power sector is the commercial viability of the distribution company. We can generate energy, but to pay for it right now is really a huge challenge, and state after state keep looking for options to bail them out, to bail its discoms and utilities, and to make them work and to make them viable. Our AT&C losses, in Madhya Pradesh, some time back, we used to call them T&D losses, which got translated as theft and dacoity losses. They continue to be very high. We have reduced them by about 10 percentage points, but still very high. 31% is a very high AT&C loss. And to sustain that loss is becoming increasingly difficult. This loss is high because my share of agriculture consumption is pretty high. So Delhi and Mumbai won't have that, but in Madhya Pradesh, I need to supply 30% of my energy for the agriculture sector, hardly any revenue coming out of it. While I am giving a tariff subsidy of 1925 crore a year, the agriculture tariff is subsidized to this amount, 1925 crore, which is a huge amount. Still, the balance which is to be recovered from farmers is just about 50% of the rest we recover. Rest all is simply gone into. So in a way, you can simply calculate this about 1,000 crore is a net loss by supplying to the agriculture sector. And this load being high, it's a huge problem for us. We continue to have a gap between our average cost of supply and average revenue that I recover. That's the main reason why I run into losses. If I put in one more unit into the system, I lose one more rupees. So we need to find out a solution to remain commercially viable while supplying this 24-hour supply. This is what we thought, that we can't fulfill this, this ambitious goal if we don't have separate feeders going for the agriculture and the separate feeder going into the domestic area. If I supply using the same feeder, if I target both the agriculture and domestic consumer, there is no way we can sustain our losses. So we thought that we need to have two separate feeders, 11 kV feeders, one going into the domestic areas of the villages and the other going for the farming activity. And accordingly, we defined the objective of the project that we launched, the feeder separation project, is to provide commercially viable, continuous supply of electricity to every household while ensuring sufficient supply for agriculture purposes. And the sufficient supply should also take into account that there is limited potential of groundwater which you need to tap. So if you run your pump 24 hours, you might start getting oil from it instead of water. So you need to have controlled supply for agriculture. That's one of the objectives of the project that we launched. So what we intend to gain out of this project is that we need to control our AT&C losses. So in rural habitation, which used to be a low voltage network, we need to convert it into HVDS, high voltage distribution system, so that people can't directly tap into my network and start drawing power. This will have a positive impact on my AT&C losses. We need to have quality power for the agriculture consumer. So my transformer failure rates needs to go down, the agriculture pump failure rate needs to go down, and we need to ensure that the general satisfaction level with the supply in rural areas actually improves. We did some scoping for the project. Looks huge. 6,262 feeders were identified for feeder separation. Some of them were covered in the ongoing scheme, but most of them was taken up as part of the project. And this when we look at the scope in terms of the detail engineering, it's actually huge of how much we are supposed to do. And in fact, it's costing also. You design a project this size, doing a detailed engineering for every feeder of 6,662 and find out how much money is to be invested. 5,157 crore rupees were to be invested in this project, which was to ensure and just to be completed in a 3-year period. Now this creates another challenge. The distribution utilities in Madhya Pradesh traditionally never spend more than 100 crore a year. 3 of them put together will use about 300 crore. So a distribution utility whose competency to deliver project is limited to a few hundred crore, for that utility to scale up its operation, go to a figure of 5,000 crore, and that too in a period of 2.5 years, brings more challenges. That how do you handle the investment of this kind? How do you effectively implement the project and do it in a manner which doesn't result into failures down the line? So we designed a project methodology, changed our model from a supply and erection model to a turnkey contract model in which the contractor was supposed to do everything by themselves. We had independent engineers for project supervision. I'm sure the persons here who knows about distribution utilities would understand that priority for a DISCOM is always this revenue. The project implementation is always the second activity that we do. So we realized that we won't be able to complete the project in time if we don't have an independent supervision consulting firm. So we had independent engineers to do a project supervision for us. We designed our contract in a way in which, after the design and its vetting by the engineer, the contractor was supposed to guarantee a 12% loss level below the DTR. The system has to be designed in a way that the loss level actually goes down. That's a T&D loss. It was not responsible for the collection part of it, but technically the loss was supposed to go down with this. We prepared bid documents through lots of consultations. We ensured that our our tenders were well received, so we did contractors conference in Delhi, in Hyderabad, in Mumbai. In fact, we don't have many contractors in Madhya Pradesh, so we always keep looking outside for the contractors to come and settle in Madhya Pradesh and do things there. And we introduced Feedback Ventures and Scott Wilson as ICT as the company for doing the project supervision. We had huge participations actually. Our contracts were very well received, and we had excellent, in fact, none of the tenders has more than less than 6 bids going for it. That speaks about what kind of procurement strategy we followed. This took a lot of time. The procurement strategy took a lot of time for us. We sourced some of our funds from ADB, so the procurement actually took about 5 to 6 months in our phases and 3 to 4 months when we approached REC for the funding mechanism. Almost all good companies who work in the distribution sector came to work with us, including a Korean company, which is the distribution company of Korea. They got awarded the project. I wouldn't say that, after doing so much of effort and hiring such excellent companies, my result is what I expected it to be. We continue to face delays. Some of the companies continue to fail and create problem for us, but we did our best to do a sound procurement strategy and followed it up. This is what I've achieved so far. In fact, we were supposed to cross 60% by now. We're still touching 33%. All the 3 companies are doing 33% of the feeders that they have done. But it's an end result actually, the feeder which has actually been separated. A lot of work has gone into erection of poles and things like that, so the results are getting quicker and quicker. With a few months delay here and there, I should be able to complete the project by June of 2013. This is the expected result. In fact, we did some numbers and found out, in these 3 years, distribution infrastructure would actually have almost a 50% improvement on its existing position. In a way, what it means, whatever we did in 60 years of the power sector being there, almost half of it is being done in this 3-year period. And the distribution companies and engineers and contractors, everybody is focused and tuned to do that. This is some of the results of the feeders that we have achieved so far. Some of the feeders that we separated, and how does the loss level look like. Some of them have done very well, some of them have not done so well. The 12% and 15% figure still looks challenging in some areas, so we need to still work on that. But the results, the AT&C loss reduction in these rural feeders actually is hugely substantial. In 12 feeders in Jawara, the loss has come down from 57% to 14.9%. So huge improvement wherever we are implementing the project. So the final results are yet to come, but let's see how does it come about. And with that, thank you so much.
Good morning, everyone. Thank you for giving me this opportunity to talk at this conference. I must acknowledge that among all the speakers who have talked about power, I am perhaps an outlier because all the speakers have a very long and strong background in the power industry. I am from the software engineering background. Even my PhD was on cybersecurity in power systems, so a very interdisciplinary domain. What I'll try and do in this brief presentation is give an overview of some of the emerging challenges to our power system. For most of these challenges, we find that we have the technological solutions, but we need to set out a clear strategic direction in front of us. Looking at some of the data, we find that despite the power crisis that we've had in the last few weeks, we've actually done pretty well when it comes to the installed generation capacity, especially in the last 10 years. In the first 50 years of our independence, we added about 100 gigawatt of generation, and then in the next 10 years, we've been able to double that. We'll perhaps add another 100 gigawatt in the next 5 years, and that's actually a phenomenal achievement. If we look at the transmission system performance, we've added about 100,000 circuit kilometers in the last in the last 10 years, and about 2 million kilometers below the 66 kV in the last 10 years. The performance here is not as phenomenal as what we've been able to achieve in the generation sector, but still this is quite impressive. And the problem, of course, lies in the distribution sector, which I'll talk about later. Even in the per capita consumption of electricity, we see that in the last 5 years, we've again done substantially well. The per capita consumption has increased by about 30% in the last 5 years. Having a look at the relation between the electricity generation and consumption with respect to GDP, we find a very interesting fact, which is that in the last 5 years, the delivery and the generation efficiency has gradually increased. So 5 years ago, we required about 0.72 kilowatt hours of generation for 1 unit of GDP, but today we require only 0.66. Unfortunately, in the consumption side, we are not doing that well. And that is a point where we have to seriously focus our attention. Coming on to some of the challenges, I did mention that we've done pretty well when it comes to the installed generation. Right now, we are just above 200 gigawatt. Perhaps we'll cross 300 gigawatt by 2017. But in spite of that, the peak demand deficit continues to grow. These are the CEA figures and Ministry of Power figures. Right now, we have a deficit of about 10.6%, and we expect that this will reach almost 20% in the next 5 years. This will actually be a very serious challenge. Of course, one way is to boost up the installed capacity further. The other way might be to have special types of generation facilities. Mr. Hiranandani talked about the gas-based power plants. But one of the areas in which we could also start focusing is to look at the demand side. If we cannot tackle this problem only from the supply side, we perhaps also need to look into the demand side and start looking into demand response, which basically doesn't mean that we forcibly cut the supply to a particular area, but how do we basically interact with the customer in a more real-time way so that we can persuade him to reduce demand when the utilities want that to happen. A Ministry of Power has actually, the Planning Commission has actually initiated this discussion on time of use tariffs, and I think that will really help in this area. The second big challenge that we think the industry is facing is the huge transmission and distribution losses. These are the figures for 2009, 2010 by the Ministry of Power. The figure is at 24%. This is the transmission and distribution loss. On top of that, if we add the commercial loss, it goes to almost 28.5%. And this figure is actually astronomical. If we compare that to many of the developed countries, Japan, for example, has about 5%. Korea has less than 4%. This is even a very high figure if we compare it among the BRICS economy. Brazil has just about 15%, South Africa about 10%, and the world average is at around 9%. We are annually losing around $11 to $13 billion from transmission and distribution losses alone. If we could somehow bring it down to the level of Korea, let's say, we could probably save around $11 billion. If that is too ambitious and we could actually bring it down to the world average, we'll still save $8 billion. That could be a huge boost to our utility sector. The third change that we feel is coming in the power sector is the renewable sources of generation. Right now we have about 25 gigawatt. We expect that it will go up to 40, 45 gigawatts in the next 5 years, primarily solar and wind. And that per se is not the challenge. The challenge is that most of this installed generation is in 5 states of India. And the real challenge will be how do we sustainably integrate these renewable resources into our existing grid. Because most of these, solar and wind, they are very intermittent and very volatile in nature. And volatility again has 2 dimensions. One type of volatility is that if you have a 400 or 500 megawatt solar power plant and suddenly you have a cloud cover, the generation falls, how do you back it up with an auxiliary mechanism? Can we actually identify some sort of efficient and cost-effective storage mechanisms which can also provide the needed throughput? That is one type of volatility. The other type of volatility is not as real-time. We all know the sun rises in the morning, sets in the evening, but that still creates a lot of problems. Let's take the case of Germany, for example. Germany has an installed solar generation of about 28 gigawatt. And in the morning, the sun takes about 35 minutes to cross from one end of Germany to the other. So within a span of 35 minutes, we have this 28 gigawatt of solar ramping up. That is not a very big challenge in the morning because at almost the same time, you also have the consumption going up. The real challenge comes in the evening when the consumption goes up, but this production starts falling in about 35 minutes. So these are some of the sort of challenges that we will have to overcome in our power systems. Having a look at some of the drivers and correspondingly some of the technologies which might help to solve these challenges. Before we actually even look at some of these technologies, the last two verticals, the system operation and application, if we would have discussed this slide about 10 years ago, we probably would not be talking about the last two columns at all. System operation would perhaps be a part of transmission system, application would probably not be considered at all. But the consumer is becoming much more important today. And if we take a system-wise, a holistic approach, then we need to consider how do we get to involve the consumer more and more into the entire system. And that is a very difficult thing to do because saving energy, reducing carbon footprint, these are some of the things that are very difficult to get across to the consumer. Because saving energy is a very difficult intertemporal choice. The human brain doesn't really comprehend decisions where you are giving up something very clear, something very tangible today for an uncertain benefit somewhere down the river. That's not really how the human brain works. So we have to identify some ways in which we can educate the customer on the importance of energy consumption, and then that would be one of the starting points. To summarize, we find that the traditional grids are gradually giving up way to the smarter grids. The term itself is not important, but more the context. Right now we have a system which has a one-way flow of energy and a one-way flow of information. So energy flows top-down and information flows bottom-up. And both the things will probably change over a period of next 5 to 10 years. As far as the energy is concerned, once we have rooftop solar at the consumer level, then the consumer becomes not only a consumer of electricity, but also a producer. So that enables a two-directional flow of energy, which then starts creating problems for the system operators. Similarly, if we have more intelligent meters with the customers, through which the customer the utility can get the data in shorter durations of time at a much finer granularity, not only can they improve on their operational processes, so typically the operational decisions would be taken by the historical data, but here you are able to get much real-time data. But at the same time, they can interact in a much better way with the customers. So both the energy flow as well as the information flow become bidirectional. And that is essentially what might change the power systems. I'll just skip some of these slides in the interest of time. I just want to mention two of the projects that we've done. We've been involved in more than 70 projects, but I'll just mention 2 or 3. This was one of the 6 projects which was awarded in Germany. This is the minimum emissions region, Merigio project in Karlsruhe. E-Energy basically started a competition where they awarded one project out of the 6 to this consortium. And as you can see, the consortium has members from different backgrounds. We have people from IT, ABB was there, and from academia as well. And the entire scope involved a complete IT integration of the meters with the customers' premises, remote control of distributed generation, setting up the entire communication infrastructure between the utility and the customer, and ensuring home area automation. So ENBW, which is the utility that was responsible for installing these smart meters at the customer's premises. ENBW also took care of shipping the data from these meters to a core platform. That core platform was from IBM, and then various other players provided these components. So SAP, for example, provided the accounting and the billing component. ABB was responsible for the entire network management, entire distribution automation. So projects of this type are not conceived by one person alone. It will require a collaboration of multiple parties. This is another project that is actually very long-term in concept. This is the Royal Seaport project in Stockholm. It started somewhere around 2010 and it will go up till 2030. The primary vision here is to achieve 1.5 ton of CO2 emission per capita per annum by 2020 and achieve carbon neutrality by the year 2030. Fortum and the municipality of Stockholm, they are leading this effort, and along with a lot of technology partners, appliance manufacturers, again academia, the Royal Institute of Sweden is involved here. 10,000 new apartments are being built, 30,000 workplaces, and there is a lot of focus on energy efficiency, local recycling, how we can alter the lifestyles of people, how we can make them become more aware of energy consumption, and if possible, cut down on the energy consumption as and when it is needed. Finally, just a short slide on a project that we've done in Karnataka. This was primarily a SCADA implementation for the entire generation, transmission, and distribution sector in Karnataka. Probably one of the largest SCADA implementations in the world. It covered about 867 locations in the first phase and another 450 locations in the next phase. So we get all that data and then we can build a network model, and on top of that, from one central control room, you can take your decisions depending on how your network is performing. Thank you very much for your time. I'll end the presentation here.
Thank you very much, Mohammad Suleman, and thank you, Dr. Fuloria. Both were very interesting talks and something new we learned, how MP is separating the feeders, rural feeders from non-rural feeders, and how they have been able to cut down on the AT and C losses. And of course, we learned about smart grid from Dr. Fuloria. Thank you very, very much. We would like to start the next session now.